Good afternoon. Welcome to course Thermodynamics of Materials. We are into lecture 127 and 128. We are discussing currently the interrelationship of two types of interaction coefficient, epsilon and E. These two types of interaction coefficient. Okay, we have considered the first one, epsilon BB and eBB. This actually we are in the process of finding the relation between them. So we actually have this is let us start. We went up to this point. And okay, it's very good. These are zeros. These are zeros. Zero. Careful. These are zero. X is 0. One point I want to mention that I made a mistake here. eBB is defined as the ln FB weight %. This is FB weight, this is log. This is one mistake I made. You should be careful. This point, the log. It's called log base 10 rather than log base E. So this you should be careful. This is the definition of eBB. So more about this, we started this, and another point is, remember these two is factorial 2. Factorial 2 is 2. Remember, this is factorial 2. So if you actually proceed, it will be next is 1 by factorial 3 and cubed dq ln gamma b dx bt etc. But we have actually considered up to quadratic terms only. So we have this. Remember, this is factorial 2. So let us move on. And if there is any equation number, I should be very careful about this. If we actually want to give any equation number to this. This is equation number, right? This is equation number 2. This is equation number 1, equation number 2. We can resume here from this point, okay? Start, okay? So this is very good. Where, now explain the terms actually. This is MacLaurin series expansion. I'll talk about this, okay? What is MacLaurin series expansion? You see, if you follow this is something, okay, unknown. This value you want to find out, xb is at xb is xb, at xc is xc, and this can be obtained from this relation, okay? And in terms of all values, derivatives, or the first term, which is non-derivative, directly ln gamma b, corresponding to xb is 0, x is 0. That is the beauty of this theorem, of this MacLaurin series, okay? All 0, 0, 0, 0, xb 0, xc 0, okay? So I give an example for your benefit. How this works. MacLaurin series, maybe you know this, but in case you have some of you have some difficulties about MacLaurin series. Why this MacLaurin series? Example. MacLaurin series. Series. Example. That will help you. This I show you, then you will understand why these are considered 0, and this is okay. This is this, okay. Suppose I consider the equation. Why consider the equation? Consider the equation y is 8x cube plus say 4x square plus 5x plus 7. This is y, and y is fx, function of x, as you know. So what is this? How what is apply? You want, if you want to understand the MacLaurin series, so see this, fx is at x is x, at x is x, means fx itself. Fx is what? It says fx at x is 0, follow, x is 0, plus first derivative del fx, whatever d here I may write, since d fx dx at x is 0. Then the second derivative, since there is no c, only x, not x or y like this, okay, just x. X is 0 plus d d2 fx by dx square at x is 0 times x square. And I made a mistake here, times x xb means x square. The last one, d cubed fx by dx cube at what? X is 0 times x cube. Now you see what happens is what? Fx at x is 0 is what? Y is fx. Fx at x is 0 is what? Just 7. See, put this 0, 0, 0, 7. The first term is 7 plus second term is the differentiation of dx, fx with respect to x. d dx fx. What is the d dx of fx? You write this 3x square, 24x square first term, 24x square, you know. Okay. I made a mistake here, as I told you. Here 1 by 2 is there. I made a mistake, 1 by factorial 2 actually. 1 by factorial 2, because you will understand factorial 2 and 2 is same. So you cannot distinguish you cannot, okay, see any difference. But here you see, it must be a factorial 3. It is not 3. Factorial 3 is 6. So careful about this point. So see, let us see. You will soon see. Okay. What I have wrote here, or ddx 24 x square, right, easily right. Then it is 8x to 8x ddx plus 5, and value at x is 0. Okay, this is the first derivative. What is the second derivative? Keep on writing second derivative. Okay, here where it is? Here it is 1 by factorial 2, right? 1 by 2, right? What is this? Second derivative. Do the first derivative, second derivative is 48x, 48x plus 8, x is 0, times what? Times second derivative x square, times x square. And last one is 1 by factorial 3 means 1 by 6. What is the third derivative? Third derivative is, it is just 48, just 48, and there is no meaning of writing x is 0, but still you write, since it is written here, times what? X cube. Now what you are getting? Tell me, 1 by 1, 7 plus x is 0, is what? 0, 0, 5 only. So 7, 5. Oh, I made a mistake here. See, this x I have forgotten to write here. Right here, this term 5 right here. I have written x square, correct, x cube. So what again see 5x at x is 0, 5 remains, and 5x plus what is this? X is 0, again only 8. 8 by 2 is 4. 4x square. 4x square plus next one is 48 48 divided by 6, 8x cube, 8x cube. You see, this has come back to this one. 8x cube plus 4x square plus 5x plus 7. So same. This is actually your fx. Fx means fx at x is this is the fx, or fx is. So this is how you get this result. So if you are interested to find f2, as you do here, f2, here you write x is 2. It is x is 0. It is 2. This is 2 square, 2 cubed, and so on. A further term, unnecessary, because this is a constant, and the difference is a fourth derivative. This is a constant, and so 0. So plus 0 plus 0 plus 0. This is an infinite series. This is infinite series, but all are zeros. After some time, this has been all have been reduced to 0. So 0 0 0, and so this is goes to infinity, and meaningless. You don't need that. So here stop here. Once it is a constant, next derivative is 0, and no use, not required. So you see, this is the whole meaning of this relation. That is MacLaurin series expansion. Okay. So this is, thank you. So if you have understood this, then let us move on. Okay. Remember this as I told you. So let me get this. Okay. See how you get back this. Okay. So if you want to get the value f2 you can find from this, but or you can place here also. Anyway, this is very easy for you. When fx is this and f2 is what? Easy. But you can put x value of x here. And where it is? X here. 2, suppose f2, x is 2, 2 here, 2 square, 2 cube. Like here. So thank you very much. So I am removing this, since I have to. So I have already explained this is factorial 2, but I am removing this. Let us move on. Next, okay, today's class. Give a equation number. Remember, this is equation number 2. Now let us okay. Where? Let me explain this now. Now perhaps it will be easy for you to follow this okay discussion and this derivation, where ln gamma b, this term, xb is xb and xc is xc, is refers to the I am writing it here, xb is 0, just little some xb is 0, xc is 0. Okay, refers to the composition under study. This is our interest. Say xb, say x silicon is 0.1, x carbon or say x manganese is 0.2. So these values, this is under study. We have given the name, generic name, xb is xb, x is xc, but that is our interest, what value it will be. So this actually will use, I tell you why you will use. You will use these relations that you get on the left hand side, this will be there. Using this relation, you will get ln gamma b at the given composition, and use this to find out activity. And activity is what? This gamma b times mole fraction b. So you get activity. So this is how actually. Similarly, I write the little while later that ln gamma c is what? Expression for ln gamma c. Just after I finish this, I write the expression for ln. So then you will use the same way. That is, find gamma c using this relation. Ln gamma c means gamma c, and then find activity of c. That you will require, okay, in your what is the equilibrium constant expression and other things otherwhere. So this is the idea. Okay. Now you'll learn more as you move on. This is where ln gamma b refers to the condition under study. This we understand. Okay, yeah. This under study. Okay. Now remove this. Remove this. Okay. Next. Okay. Give a simple and what. So this term I have explained. What is this? This is ln gamma b. Xb is 0. Xc is 0. Is nothing but ln gamma b. Gamma b. Xb is 0. Because this is, there is no meaning of Xc is 0. Okay. Because it is about gamma b. So at Xb is 0, and this is refers to a binary system. What is the binary system? A, B. Solvent. Remember, I have already mentioned at the very beginning. Beginning where? Ternary system ABC. A is the solvent. A is solvent. So B, Xb is 0. What is the name of this? You know, ln gamma B 0. 0. Okay. So Xc, presence of Xc, C, presence or absence does not matter. Okay. This is actually the ln gamma B. You have learned a lot about gamma b 0. You know these things. So that actually ln gamma b at Xb is 0. So this is what? This refers to binary system. So I'll write this ln gamma b 0. This is a property of the. This is a property of the what is called. This is the property of the binary system AB. Binary system AB. System AB. Component C is absent. Remember, gamma Xb is 0. B is not absent. It is AB binary. And what is gamma b 0? Remember, gamma b at Xb is 0. The whole thing. Okay. Gamma b is a binary. Gamma b is a function of Xb, and you take the value of gamma b at Xb is 0. That can be taken from the activity composition, and you can take the, if it is Henry's law line. Okay, you have a Henry's law. It is take the slope of the Henry's law line. You'll get this. Xb is 0. So gamma b 0. So it is actually binary system property. I tell you what now. Before I proceed, this is a binary property. This is whole thing. The left hand side is ternary. Is it? Xb is Xc, Xb is Xb, Xc is Xc. This is the question under study. This is the problem. What is the value? We are interested. What is the gamma B? Say gamma B for say gamma carbon. Then what is this? For the composition of X carbon 0.1, X manganese 0.2. There can be more if it is quaternary, pentennary. So this actually, so this is the question. So this is the answer. So remember, this is ternary, but you will see some are here binary and some are ternary properties. No problem, absolutely no problem. So this, for example, the starting is binary. Then I give you beforehand so that you understand. When this is all B and B, this derivative see B and B, then it must be a binary. AB, A must always be present. A solvent is present. A solvent B solute have written somewhere. Yes, I have written here. A solvent B, C, D, E, F, all solutes. Here actually ternary, so B, C solute. So, so it is binary. This is what? Oh, this is numerator is gamma B, but denominator is Xc. So it is a ternary property. Repeat, come back here. This is again gamma B, Xb, binary property. This is again gamma B, Xc, ternary property, means ABC property. And last one is again gamma B, Xb, Xc. So it is again ternary property. So this I explained you. So you will get this as you go along, that I'll explain. I'll specify them as binary or ternary. But this you will get. So this term we have discussed. This term we have discussed. This term we have discussed. What is this? And okay, then okay for XB and the derivatives, and the next are all derivatives. Are derivatives. You see clearly are derivatives. X is, remember, x is 0. X is 0 or 0. These are zeros. So, and the derivatives are also, and the derivatives are also for the limiting case of, for the limiting case of, zero concentrations of concentrations zero concentrations of all solutes, that is for XB is 0 and XA is 0. You clearly see XB is 0. It's clear, it's written there, okay, and it's written here also. All derivatives, okay, and also this is also, okay. So this side. Next is what? Okay. Acha, it is better. Acha. Remember, never forget. We are discussing this part. But these are the preparatory. We are getting some. Okay, this we are trying to explain this. Okay, these terms are relevant terms associated with this. So it is. This is our question. Okay, this first item. EBB. I'm sorry. Epsilon BB and EBB. Don't forget this. But it is better. I should write where I should write. I don't want to. Okay. I do one thing. I can remove this also. These two definitions, defining relation. I don't want to remove just now. Okay, gamma B is XP. Okay, here. Acha. Maybe I can write also here. It can be shown that this. Let me write this. And there. It can be shown that it can be shown that through a lengthy procedure. Through a lengthy procedure. Through a lengthy procedure. Through a lengthy procedure. Reference already given. Reference already given. What is the reference? Already given in lecture 109. In lecture 109, 110. This is already given. What is the reference? Dinabandhu Ghosh. This is my name. Ghosh. Metallurgical and material transaction B. Metallurgical material transaction B. Material trans B. I'm repeating this already given to you. 2010 2010 volume B, volume 41B, page PP 1274 to 83. That, so it can be shown that through a lengthy procedure, shown that can be shown. I'm very sorry, shown. Oh no, this that is here. It can be shown through a lengthy procedure, very lengthy indeed. You guys go through this paper, okay? That what you'll get from this, what is the outcome of this relation? This that I start from here, this point. Not this point, start here. Give a start here. Give a start here. Start here and start. What you will get? The lengthy procedure is this. Final is follow this. Let me write this one. You take up this ln gamma b is this is ln gamma implied for this the given concentration for which we are going to find out ln gamma. So ln gamma means for the given composition. Understand? Ln gamma b everything. So short. Okay, unnecessarily don't write this. Ln gamma b is what? This already I have seen. Follow ln gamma b0. Ln gamma b0. But next you take up as ln gamma b0 plus epsilon bb xb minus half xb square plus epsilon cc minus half xc square plus epsilon bc. See here, epsilon bc, these are coming, okay? Bc xc minus xb xc. So this is actually this. Oh, by the way, it's correct. It's okay. Remember this third bracket here followed this the previous one. This is for the these three in the third bracket. These are the second derivative, and these two in the third bracket first derivative. And this is ln gamma b at xb0, xc0, and that is ln gamma b0. So this you will get. And this is given. So let us have an equation for the important equation 3, where epsilon bb is, this can be referred to these derivatives now. Now these derivatives, okay, because from this you will get this. From this you will get this. Source, this paper, extensive, lengthy, thorough, you will get this. And this is very important relation, okay. Epsilon bb is, epsilon bb will be this gentleman. So let us write this, but okay, just take down what is epsilon bb, but they are hidden here, okay. This is hidden here. So okay, so what is this? Del, see here, del ln gamma b by del x b. Alright, so then you can give this, or you write here. You give a bracket here. Xb, or shall I use the xb is 0. This one. Xc is 0. X is 0. Okay, this is eBB, and is what? Is as I told you. See, x is 0 is meaningless. B and B, so it is only AB binary. Is what? Del ln gamma b by del xb, and xb is 0. Like this. xb x is 0 is removed. So it is only about B, and of course solvent. Solvent is always there. Okay, this AB. So this is a property of the binary system, as I already told you. So you get this. This is a property. So what is epsilon BB? This one. Okay, this I've written somewhere here. See, I've already defined. And where it is? Where it can be found? Okay, see. So, so what is this? This is a property of the binary system AB. Again, you write this thing. This is a property of the binary system. Binary system AB. Component C is absent. Component C is absent. So never forget, A is the solvent. A is present. B, C are solutes. A is present. For example, A is what then? If I talk of carbon, silicon, manganese, say, and then A is what? Iron. In steel making system, iron making system, A is iron, and these are the solutes. Okay, good. This is epsilon BB over. What is epsilon CC? Gradually. Let me write here. Yeah, maybe. Epsilon CC is what? Epsilon CC is what? Actually, you can see half x square. X square is where? This here. There is a half here. So epsilon CC is nothing but the minus of this. Let me write. Oh, okay. I'm taking this. I'm taking this little letter. Let us go systematically. Epsilon BC next. See, epsilon BC. Epsilon BC. I'm giving all definitions which are involved in these four relationships that we'll find. Here. See, epsilon BC will be there. So epsilon BC I'm giving. In this case, epsilon BC is not needed. But through this MacLaurin series, we are explaining what is epsilon BC, so that when we take up this, we don't have to explain what is epsilon BC. You will understand from this. Epsilon BC, okay, epsilon C, all I'm giving now. Okay, so whatever for this 1, 2, 3, 4, whatever definitions are required, defining relations, these are defining relations. Definition or defining relations are given now. Okay, so in this context I am giving, so that later on I don't have to. Then I will have to directly use this epsilon BC is what? Okay, epsilon BC is what? I tell you, as you see, epsilon BC XC minus. Okay, so what is this here? XC is where? I have this one. D del ln gamma B by del XC. This is at, I'm doing this at this XB is 0, XC is 0, and this is a property. Again, tell me, this is a property. I've already told you. This is a property of the, since B is there, C is there, so ternary system of the ternary system A, B, C. Here, but I don't have to mention that this is solvent. For example, iron, and B and C are solutes. Okay, like say manganese, say carbon, or say silicon, or phosphorus. Okay, this is a property of this. So good boy. So two things are done. Last I am removing this. These are not needed. Let me proceed. Then gradually I will remove by wipe of this. Okay, gradually. Last is, from this I will get this water. 1, 2, 3. I have explained 1, 2 I have already, and this is at the beginning it has been explained. So what remains? Epsilon CC. Epsilon CC actually very easily minus half x square. Where is x square? There. It is related to this. This is half this x square. Is actually minus half is epsilon cc x square. So x square common, half common. So this epsilon cc is nothing but negative of this. Is minus, all I cannot explain, because this you have to go to the paper, or otherwise you follow me. Okay, this will be enough for our current job. Okay, for the current okay, current work. Okay, that is the relationship, interrelationship. Okay, minus what? See, x square is minus del square ln gamma b by del x square, the second derivative, at e right here, xb is 0. Okay, okay. Since I am giving first bracket now, so unnecessary give first bracket. Xb is 0, xc is 0. Now tell me, this is what property? Property of which system? This is BC, ABC, ternary. So this is actually ternary property of the system. Right here. I will write something here, equals to, coming to this. First, let me write, this is a property of the ternary system. This is a property of the ternary system. Ternary system. ABC. But incidentally, these can be shown to be, I am removing this. This line, no problem. These can be shown to be is del, all are del, partial derivative. Del ln gamma c by del x c under xc is 0 and shall I write this? X is 0, xb is 0, it is better. Write both. X is 0, this can be shown. This can be, actually, when we write this, is what? Tell me, this you will of course see C, gamma C, xc. Oh, B is not there, B is redundant. Okay, so it is only a binary property again, but it is a binary between A and C. AC binary. So what is the right once more? Just simplify this. Del ln gamma C over del xc, and just write xc is 0 only. This is the definition of epsilon cc. This is the definition. This whether okay, how this is equal to this, how this is equal to this, say this equals to this. See, this second order derivative and property of ternary becomes a property of the binary. This is a property of the, right? This is a property of the binary system. Which binary? Tell me. A, of course, solvent, and it is about CAC binary. B is absent. So this is interesting. This is a ternary property equals to binary property. See, this is a ternary property ABC, but this is a simplified version, and this can be, this equation, this equality was established in this paper. So this is very important establishment, and this okay, this relation. So as a result, we get, now I remove this line, not required anymore. Okay, this. So what shall I write here? Giving this. Okay, that's it. So I have already explained this term, this epsilon bb, epsilon cc, epsilon bc. Epsilon bb, epsilon cc, epsilon bc. Right. Okay. So they will be used in this 4 interrelationship, which will be considered in turn. Okay, so first will be considering this, but we have little bit preparatory work still left. So this is the first part. Second part, then we will actually take up the relation. So let me remove this. This is removed. Sorry, I'm very sorry. This is the first phase. Second phase is the way I started. Similarly, I have given equation number 3. Okay. Similarly, you start with this. Similarly, in a similar manner. Similarly, starting with ln gamma c is a function of xc xb. Previously, I started with, I have removed this. I started how? Ln gamma b, all these things. Ln gamma b is a function of xb, xc. Okay, 2 independent. Xc cannot be dependent. Okay, only 2 will be independent. Xa, xb, xc, because they are this sum to 1. They are bound by the relation xa plus xb plus xc is 1. They are bound by this relation. So 2, very good, like before. Only similarly proceed, or the MacLaurin series, starting with this. Now see, call it equation 4. We have to 3 here, 4. The MacLaurin, again MacLaurin, the MacLaurin series expansion, again expansion, MacLaurin series expansion in a, right in a similar manner. In a similar manner, start with this, start with the relation the MacLaurin expansion so here give this relation, the MacLaurin expansion gives expansion of ln gamma c. We understand this now up to quadratic terms only, like last time, up to quadratic terms only. What is this? Gives the following. Gives the following. Gives the following. What it gives, you know very well what is that, right? You write yourself MacLaurin series, you understand ln gamma c at the desired composition of xc is xc, xb is xb, is what? Tell me, ln gamma c at, you write all referring to zeros of these two. Xc is 0, xb is 0, plus tell me del ln gamma c by del xc at xc is 0, xb is 0, tell me, plus, okay, plus give the first derivative. So this plus del ln gamma c, del ln gamma c by del xb where it is xc is 0, xb is 0. So this first derivative is all over. Next the second derivatives and half times shall I write here? I write here. Where I shall write? I write here plus here I have to write half. Half means factorial 2. Okay, del 2. Write this. Del 2 ln gamma c by del x c square. I made a mistake. What is this? After this, just not the derivative times this xc. Recall MacLaurin series. The example will be good enough to understand. And this xb. Here again you write, give this xc is 0, xb is 0 and xc square. I'm kind of repeating what I did just in the first case. Exactly. Plus, tell me next is del 2 ln gamma c by del xb square now. Xb is 0, xc is 0. Oh, sorry. I'm writing first x is 0, so maintain that. Xb is 0. You understand this. Times, never forget, never ever xb square. Two terms. Last term is, again write del 2 ln gamma c over xb xc, and I do not know whether you can, xb is 0, xc is 0 times what? This time xb square. This is xc square. This will be xb xc. xb and third bracket closed. Again you see all are, these are derivatives. So here, so again like last time I should write this ln gamma c refers to like this, like last time I write this. So what I shall say here, this I want to save this. This you have already seen this. Okay, how shall I? I don't want to disturb this. I want to maintain this. I have defined this. Okay. eBB. As for a while, let me keep this. Since I have already written here, so remove from the top this topic. This you remove. Topic of broad topic is solution thermodynamics, but this is the subtopic. Okay. From this I write here. Right here. Let us see how much I can manage. Is this where ln gamma c, xc is xc, xb is xb. I told you that ln gamma c similarly will find out. This expression, the whole utility of this relation is that it allows us to find ln gamma c means at the desired composition under study, and hence gamma c. And then from gamma c times mole fraction c xc, I will get activities which we can use at, okay, at the required places. Activity gamma all will be known. Okay, using this relation. So how to, okay, so okay, this is very good. Okay, so start. So what is this? This represents like last time. Gamma c refers to to the composition under study. To the composition under study. I am writing everything so that there is no ambiguity in your mind. There is no confusion in your mind. Composition under study. What is the composition? You tell me. XB is right here. XB is XB, and XC is XC. The left hand side is the our okay, our is of our interest. Is the term of our interest. This is the unknown. This we want to find with the help of right hand side. The right hand side data, for example, where this data will be available. These are called interaction coefficients available in the literature, the data book, textbook. So we substitute and get the values. Find this. This will be our actually next next step when we take up problems. Okay, numerical problems. So let us follow. This is what at the component XB is XC, XC. This is ln gamma C. First term is okay. This is okay. What is this next one is? Next one is like last time. Tell me ln gamma C XC is 0, XB is 0. Again remember B is meaningless here. It is gamma C about A and C. So this is ln gamma C XC is 0 alone. This is actually XC is 0. This is XC is 0. This is a property. This is a binary. This is a property of the binary system. Binary system. S A. So what? A must be there. A and C. Like gamma B0. And what is the name of this? You tell me. Right here, and at the same time, right here, B is absent. Component B is absent. Absent. And what is the name of this? ln gamma C0. Remember, gamma C0 is value of gamma C at 0 concentration. Henry's law, all such things. Like gamma B0, gamma C0. So these two terms I have explained. Okay, again, as I tell you, you tell me which is this one will be which binary property? This is binary incidentally, right here, binary already given. Gamma C0 is wrote just now a binary property. Yes. Achha, tell me, this is binary or ternary? Yes, C and C binary. CB, oh no, ternary. Achha, what is the binary? AC. What is the ternary? ABC, CB. So both CB will be involved. A, CB, ABC. Ternary. Here, CC again, binary. CB, ternary. CB, ternary. So this is, actually, this you should understand. The property. So up to where I am now, I am here, ln gamma C0. What else I should write here? And the derivatives are also the similar in the last, as in the last time. Okay. Actually, at least this one, first one, I am writing somewhere. This we are discussing eBB and eBB1. I want to get this space. I want to get this space. Actually, the first one is right. One is right here eBB and epsilon BB and eBB. These two. This is I'm making something. eBB is defined as already given to you. Already there. And this one also. I'm sorry I removed this, but eBB I still keep it. Okay, but so this I have not started yet. eBB is the next one. Okay, let me finish this part. Okay, just finish this part. Yeah. This first one is epsilon BB and eBB relation. Epsilon BB is defined as, I have removed this, but it is already here. Yeah, it is given here. And the eBB is here. Since I have not started yet, so I'm retaining this. I'm just okay, saving this here. Okay, good. So anyway, second is what? Ln gamma c is 0. And the derivatives are also like last all the derivatives, all derivatives. And the derivatives are also for the limiting constant, for the limiting case of, just I am writing, repeating these phrases, these sentences. Limiting cases of, in case of 0, limiting case of 0 concentration of solutes, 0 concentrations of all solutes, of all solutes, e.g. like okay, that is for Xc is 0 and Xb is 0. That two solutes. Yeah. So this is understanding. It can be shown as referenced above. It can be shown Acha, I am writing eBB just this is eBB and ABB. eBB I am writing somewhere here. I am writing eBB and then doing this line. eBB, I am just saving this, saving. eBB is what? Del log AB weight %. I'll show this today, no doubt. Show this, everything I'm showing. So this I'll show. Just okay, a couple of minutes later only. Okay, just shortly afterwards. Okay, AB by over del. This is log B AB weight %. Remember what is this? AB mole subscript weight %. AB mole fraction, AB weight %. AB mole log AB weight %. Guys should give a bracket here. What is this? Already bracket is there, no? So it is better d log weight % by d weight % b weight % b is 0. Yes, I am saving this. When I will prove this, I will actually, you will see that there are that I have got identical relation. This I have saved epsilon BB. I am is here. Okay, so I am removing this line. For you, the property of binary solution. Property of binary solution. It is understood. Okay, I am removing this line. So now start here. Continue. It can be shown as referenced above. As referenced above. Which reference? That reference I already gave you. Okay, mid-trans reference, mid-trans journal reference. As a reference above, as reference above, what you can write, what you can see. Similarly, tell me, ln gamma c is this one, this gentleman. This where it is? Ln gamma c is short. Means this is the left hand side. The gamma c at the desired composition is what? Like here. Ln gamma c is ln gamma c 0 plus epsilon cc xc minus half xc square plus epsilon bb minus half xb square plus epsilon bc, cb rather, cb. Oh, it's okay. There slightly no problem. Figure is exactly as before. Good, good. ECB. ECB is what? XB minus XC XB. Give a equation name. What is the name for this Ln gamma C is this? 6. 6. What is the 5? I forgot to write the 5. This is the 5. This is the 5. Equation number 5. I forgot to write actually. XC, XC 5. This is the 5. Equation 5. This is the 6. You can check a little bit here. Suppose minus half xb square. Half, what is the xb square here? So this gentleman minus of this is epsilon bb. But I'll discuss on this. Okay, actually this is second derivative, but can be related to the first derivative through a rigorous proof. Okay, this can be shown. This has been shown. Okay. Similarly, you can see epsilon cc xc as epsilon cc xc. Epsilon cc is this one is xc like this. Okay. So this is okay. 6. Next is what? Oh, by the way, very interesting. You actually see if you follow this, you can easily follow that. Just replace B by C. Replace B with C. Ln gamma C 0. ECC is XB. This is XB. XC minus half XC square. ECC means EBB. Yeah, I'm sorry. Epsilon CC means epsilon BB minus half XB square plus half epsilon CB. Okay, here CB. Right. Here BC, it will be CB here. XC, XB, XB, XC, XC, XB. Not at all difficult, okay? If you follow one, if you understand this, then you can easily do yourself. 6. Given this 6, now where I should write, like where now this is actually the time I can remove this, no problem. This all are used up, all used. I only wanted to get this, I only wanted to retain this relationship, this equalities, this defining relation of what EBB that defines epsilon BB. I'm sorry, epsilon BB defines and relation also equals to thus define. Similarly, 3 I have already, and I will get 3 from this side also. So you will be in good shape, and you will have the preparatory for these proofs. These proofs, 4 proofs are there. I have removed this. First one is I have written only because space problem. There are more total 4 interrelationships, 4 interaction coefficient interrelationships. The first one I have written there. I'll take up. I will write once more. But let me finish this preparatory part. Okay. So right where? Oh, no. Give a star here. Give a star here. After this, star or double star. What will give you? Give a double star perhaps. Double star. Give a line here. Border here. Double star where? Very nicely. Okay, where epsilon cc is I have removed this. Okay. By the way, I have removed this here. It could be shown actually. D ln gamma c by del xc at, as you know, you always write x is 0, xb is 0 first, but then noting that these are all c, so it is xb is 0 redundant ln gamma c by del xc and just xc is 0. That's it. Xc is 0, and this is a property, right? As I told you already, this is a property of the binary system. So this is a property of the binary system. What system? Binary for which binary? This is which binary? Solvent A. A must be present. A C. No. System A C, not A B. See, B is absent. This you have to be careful when you carry out experiments, and we'll try to find a interaction parameter. Very important data, common unknown data. That this is a binary property, this is a ternary property, and I have to get the result consistent with the definition. So these definitions are clearly given. First one, epsilon cc. Next is epsilon bb. bb is actually, I tell you what, if you actually this cc, epsilon cb first, let me write epsilon, oh sorry, epsilon cb maybe. Epsilon, here, epsilon cb. cb is what? Epsilon cb is right here. Epsilon cb is what? Del ln gamma c by del x. I wrote, I forgot to write this. This is this, that this is a ternary property, is a binary property. Second derivative, first derivative, but still these are equal. These two are equal. This is shown by in the paper. In the paper, okay, thoroughly proved. So I write this, that this is this, that this is this, that is finally this is this, to be, I wrote here, I forgot to write that. This will be to be, write this, to be shown, to be shown subsequently. To be shown subsequently. This one, this equality, will be shown subsequently. Or say this definition, ECC. ECC finally, I'm sorry, epsilon CC is this, will be shown subsequently now. This is the time. Okay. ECC, oh no, ECC I have taken up. ECB I have taken up. Okay. Okay, anyway, I'll take up this. Okay, next. Next I'll take up. Oh, sorry. No. Correct. So the epsilon cc is this, and then I said this will be this, to be shown subsequently, and this is subsequently. Here it is dln gamma c dxc. That these two are equal, I told you in the paper. So this is actually, from this relation actually you get epsilon cc is this, as I've already given this expression. Epsilon cc coming following this expression is this. This epsilon cc is dln gamma c over dxc, xc is 0, xb is 0, and finally x is 0. So this I showed again. Finally, ECC is this, and here also this actually. So shown subsequently. And now next is this epsilon cb. What you write from this? Similarly, del ln gamma b del xc, del ln gamma b. This is the effect of C on B. The effect of C, concentration of C on the activity coefficient of B. This is the meaning of this. Influence of the superscript. Influence of this on the activity coefficient of this. This is influence of this on this, same C. Influence of C, of the component C on the component C. Means it is called self-interaction. Self. This is ternary, self-interaction coefficient, ternary. Effect of C on B. And now it is what? The opposite. Effect of B on activity coefficient of C. These are actually, you clearly see what is this? What you see here? What you see here? Effect of Xc on gamma B, activity coefficient of so this. So epsilon C will be exactly this. Replace B by C, exchange B and C. Del ln gamma C by dx del x B. Xc is 0, xb is 0. Tell me, is binary or ternary? C, B, ABC. So this is a ternary property. And in fact, now I tell you the third interrelationship that I have removed, though, but it is already written in your papers or in your videos, that the third one is to prove this equals to this. Epsilon BC equals to epsilon C. That is very lengthy. This will take up. First I prove first two. First two I will prove. This is the first one. The second I will take up today. Okay. This is a ternary property. The property of the system ternary system ABC or ACB, right? You may write ACB, ACB or ABC. Okay. Ternary system ACB. Okay. And last is obviously see last is eBB. eBB already I got this eBB. Yeah. Okay. So eBB is what? Right? Is I cannot show you here because I have removed this. If you do this, you will see it is minus second derivative. What is that? You can check these relations that I have removed there. Because eBB is attached with where I'm discussing eBB is ln gamma B, ln gamma C. Oh no, I cannot show that is I have removed actually. eBB is attached to it actually. I tell you what with actually eBB xb square actually xb square. This since I have removed this, such I cannot. But you will check this. eBB is actually you will do this minus second derivative del 2 ln gamma C by del xb square, and again you know this is xc is 0, xb is 0. This is a ternary property. This is a ternary property. Right? This is a ternary property of the system ACB or ABC. But EBB very simple previously, and actually it is also same. This will come back here. Is what? Not the second derivative, but the second derivative. It is correct also. This 100% correct. But since this is related to a much simpler relation, this can be shown. This can be shown. Where it is shown that this is equals to this. Where it is shown in the paper. In the paper. So I am writing is. You tell me you already have this. That cannot be violated. Del xb at xb is 0. Okay. This is This is already shown. Where it is shown? Yeah, already shown, and this is already shown, and this is a property of the property of the which system? Which system? Already written here. binary system AB, of the binary system AB. That's it. That's it. Okay. 1, 1, 2, 3, 1, 2, 3. See, interesting part is this, that the second derivative with negative sign is equals to this first derivative. And this is a ternary system because it involves gamma C x B, but this involves gamma B x B and binary system AB. But they are equal, exactly equal. That is to be shown, that has been shown in the paper. So no problem. So EBB is already here and here repeated. EECB, EBC are given, okay, their own way. And what is epsilon, I'm sorry, epsilon BB and epsilon BB giving the same result on either side. Epsilon BC, but this is epsilon CB. Their definitions are given, defining relations are given, and we will prove that these two are equal. That is the third item. First two item I will take up today. Third item and very lengthy. That I will do. Okay, we have to consider equation of continuity. This I will take up actually. Let us hope that I will finish the first two. Then this is the third one, and the fourth one is related to the E parameter. E parameter. I will just start now. Okay, very good, very good. And what else? So this is the epsilon CC. This is the epsilon BB. Okay. So epsilon BB is already there. Epsilon CC here and epsilon CC here. Okay, both are same. See, this is repeated. This is this repeated. This is repeated. Only these two are not repeated, but actually they are repeated in a sense because they are equal. But that is to be proved. Okay. But these are directly epsilon BB, epsilon CC, epsilon CC. So only 1, 2, 3, 4. Okay, these relations. So anyway, I will actually, what shall I do? I have to move on. This part is over. Okay. Next phase. Remove this. Remove this. Remove this. Remove this line also. This line also. Only I'm maintaining this relation. Some of the relations I keep here. See, epsilon BB is given here. Epsilon BB is given here. So I don't want this line. Happy? Epsilon BB, epsilon CC is given here. So this line also I don't want. This line also I don't want. What I have kept actually 1, 2, 3, 4. Okay. This actually, this I don't do. Actually I write here. I write here rather. Remove this. I'm writing this only. Top. Epsilon BC is just this one I'm writing. Del ln gamma B del xc at, tell me, xb is 0, xc is 0. I'm not where? Where have you? These 4. For the timing, save this 4. Save this 4. 1, 2, 3, 4, and remove this. This is I will repeat it here. So all remove. Quickly take up next one. You have noted that I am talking of only epsilon interaction coefficient. Only epsilon interaction coefficient I am talking about. Not this E. What is this E? The definition is given. Oh, definition I have removed though, but you know, EBB. For space problem, I wrote here somewhere, but I have removed this. I have removed that. Okay. EBB definition, shall I write somewhere? EBB. I wrote previously E, I mean E, right? eBB I am writing here for you. eBB, please tell me, can you remember what I wrote? And I made a correction today. What is this? Tell me log FB Henry activity coefficient. And what type? Weight percent type. Henry F Henry activity coefficient. This is what? Raoult's activity coefficient. D log over D weight percent B, and no surprise that I have to give a weight percent B is 0. Weight percent B is 0. This is the definition of eBB, which I have removed actually. And epsilon BB, if you ask me, is before your eyes. This one, epsilon BB. Okay. So their relation we consider, but before this I have to introduce eBB now. Epsilon BB over eBB defining relation, then their connection, their interrelation. So next is eBB. So what is this? Start quickly. Next, remember this time we will discuss about Henrian activity coefficient. And which activity coefficient? Weight percent type, not mole fraction type. FB weight percent. Okay. What is this? Next, the composition dependence. I think I have got enough space, no? Next, the composition dependence. Just I am paraphrasing what I wrote previously, same way. For Raoult's activity coefficient, I am writing for Henrian activity, and same approach. You just see if there is any change that I will mention. Yeah. Next, the composition dependence of the Henrian weight percent of the Henrian weight percent type activity coefficient. Henrian activity coefficient. What is the symbol? Tell me. Henrian activity coefficient. What is the symbol? Tell me. AB, you know very well. AB weight percent. That's the symbol. AB weight percent. Okay, good. In the ternary system, ABC again as before. In the ternary system, ABC. Again, in the ternary system, ABC. You can write here. A is solvent. BC solutes. Okay, in ternary system ABC can be written as follows. Can be written as follows. Log. Remember, this time we are considering log, not ln. Log FB weight percent. What we wrote last time? Ln first equation. First, ln gamma B is function of xB xC. What I will write now? Log FB weight percent is function of weight percent B weight percent C. Instead of xB xC concentration type, writing weight percent B weight percent. So there both are expression of concentrations. So function of weight percent B weight percent C, no problem. And A is of course their solvent. A is the solvent. I am giving the solvent. Say you may consider always iron is the solvent. If iron steel system, iron is the solvent. So give a name to this equation. I think so it should be 7. 6 already there. 7. Okay. The MacLaurin. Next take a MacLaurin. Next take a MacLaurin. A similar approach. Similar. Only E will turn up rather than epsilon. Follow me. Next is the MacLaurin series expansion. MacLaurin series expansion of log FB weight percent, log FB weight percent up to the linear terms only. Up to the linear terms only. We are not considering quadratic. Up to quadratic, it is not required for our purpose. So, no, not extension up to the quadratic terms, like last time, up to quadratic, just linear, the first two terms or three terms. Quadratic terms is not required for our purpose. So, the MacLaurin series expansion up to linear terms only gives the following equation. Okay, what is that? MacLaurin series now. We are supposedly expert now. So what shall I write? Log exactly FB weight percent, and again write like last time. This is weight percent. What? This is the most important one for us. This is the unknown. This we want to find out. This we would like to find out using the right hand side expression where interaction parameters in the form of eBB, E will appear, and those values are available. So very nice. So log FB weight percent, and what is this? It is a weight percent B. Weight percent B is weight percent B. It can be 0.0, okay, 0.02%, 0.5%, etc. 0.5%, right. 0.4%, 0.3%. Okay. Weight percent C is weight percent C. Again, I repeat you, this is a ternary for the ABC system. ABC. But some in this expression I have seen, some are binary, some are ternary. Very interesting. Some binary data, some ternary data will make up for this ternary value on the left hand side. Is what? Next is tell me what? Oh, remember at 0 value. First term, the log FB weight percent. This FB weight percent, you understand? This is actually over. Tell me del weight percent B. Okay, you understand? So I can give bracket, but it's okay. I have to give a bracket here. What is this under this? Tell me. Weight percent B is 0, and as you know, weight percent B, weight percent C, all are 0. Then we'll see if anything is irrelevant. Then I will discard. For example, here you see W percent. Weight percent C is 0, is irrelevant. Is what? Plus. Continue. Plus. Oh, by the way, sorry, I am very sorry. I wasted time. First one is what? First one, this value itself, log FB weight percent. I am very sorry. At what value? Like ln gamma B at xb is 0, xc is 0. Then I said, oh, not necessary, xc is 0, not needed. ln gamma B at xb is 0, and that is ln gamma B 0. So like similar approach. If weight percent, tell me, write this. Weight percent B is 0. In principle, you write this. Then you see if anything can be discarded. Okay. First term. Second term, keep on writing first. First write D log FB weight percent over D means del weight percent B, del weight percent B. FB weight percent, del weight percent B. At what weight percent B is 0. That is the principle of MacLaurin. Both are 0 times weight percent. This is the first term, and last another term. I don't have space here, but I have to write. No way I have to write. Let me write del. Similarly, del log FB weight percent, over del weight percent C, same effect of B, effect of C on B, effect of B on B. That will be, it will be self. This will be ternary type. Okay, this. Okay, you'll learn more when I give this type of. Okay, then what it is, tell me. Weight percent B is 0. This derivative is at weight percent B is 0. Weight percent C is 0 times weight percent C. Don't ever write here 0. Oh, that will be disastrous. Don't write. This derivative at weight percent B is 0. Weight percent C is 0 if it is applicable. And at weight percent B is 0. But that doesn't mean this is 0. No, this is the percentage. Weight percent B is 0.01%, 0.2%. Weight percent C 0.3. This derivative restrictions and these values. Okay, it's very good. And second, next you have none left because quantity terms you are not considering. So you have got all these things. Okay, only the what is this called? If you use the previous, if you use the previous, okay, don't hold it. Okay, very good. Where? Right. Where? Quickly. Where log FB, one by one, I am clarifying. Log FB weight percent at weight percent B is weight percent B, like last time. Weight percent C is weight percent C. What it reflects or what it says refers to the, well, it refers to the, draw a line here. Refers to the composition. Which composition? This is the composition understudy. This is the composition left hand side understudy. Refers to the composition understudy. This composition understudy, say it is 0.02. It will be here 0.02. This, of course, very much so. Okay, understudy, composition understudy, understudy. What is that? What is the right? Repeat. What is the composition understudy? You understand? Weight percent B is weight percent B, and weight percent C is weight percent. Write this once more. What can I do? Okay, write this and log. Yes, this one. This is very critical. Next, so this term I have explained. Next, this term, log FB weight percent under weight percent B is 0. Weight percent C is 0. What it is? What is this? What is FB weight percent? Is what? Log FB is what? I tell you what. Okay. This is a property of the this is a property of the yes, is what? Log FB weight percent B is 0. Since it is about B only, B is 0. Is a This is a property of the binary system. This is a property of the binary system. Binary system. Binary system. What binary system? Tell me. AB. Binary system AB. Is the solvent. Component C is absent. C is absent. Okay. Now this is actually, I tell you what, this is 0. This is 0. Why, sir? This is 0. Follow this argument. Because if it is 0, recall. Rather recall. Why it is 0? Recall. AB weight percent is what? Tell me. 135. Oh. Recall AB weight percent is what? It's okay. It's okay. Everything okay? Pictures are okay? Oh, 25 minutes. Recall AB weight percent is what? AB mole fraction. Recall. Oh, I have written. Fortunately, I have saved this. Saved this. Very useful now. Very useful. AB mole fraction. The two Henrian activity coefficients are equal, are same. Is what? The value is what? Before you. Gamma B by gamma B0. Okay? Is gamma B by. And at this weight percent B is 0, and at weight percent B is 0, that is at XB is 0, XB is 0, gamma B is what? Can anyone tell me? What is gamma? At XB is 0, gamma B at XB is 0 is called gamma B0. Gamma B is gamma B0. And this gives FB weight percent. How much? If gamma B is gamma, if gamma B by gamma B is gamma B0, this is 1. So FB weight percent is 1, and log FB weight percent is 0, and that I have written. Okay, so this term drops away. This term drops off or drops out. So these two terms will be there. So let me write this. Now I'll work from here. I'll remove this. So this is equation number 8, perhaps. I remember this must be 8. Equation 8. I don't want to disturb this part. That's why I'm actually taking from the top. I'm using the top part again. Remove this. Now start. Okay. So equation 8. Equation 8 can thus be written in a simple form, in a simple manner, But tell me, log FB, you don't have to write this, okay? It is implied. Log FB is what? This term drops 0, and this is what? This is known as famous. I wrote here, nah? This is your famous. If you have recorded this, noted this, I have written here. I don't know whether you can see this here, but this is eBB. E not epsilon, eBB. When you are using Henrian activity coefficient and a derivative with respect to weight percent B, not XB, and FB weight percent you are considering not, that is Henrian activity coefficient, weight percent type, not Raoultian activity coefficient, gamma B type. When it is gamma B, when it is XB, that will be epsilon. That will be epsilon, as you see here. as you see here, gamma is here, eBB, gamma B, XB. Okay. So this will be our, sorry, this term drops, eBB, and this is 8% B, and similarly this will be EB, EBC. Again same concept, a raw concept, that effect of B on B, effect of composition of B, concentration of B on B, on here, effect of this superscript, effect of the superscript on this, on the base is B, the effect of the superscript concentration, effect of B, concentration of B on the activity coefficient of B. What type of activity? Oh, right here. Don't ever log FB, but don't leave it there. What type of FB? Henrian, two types FB 8%. So effect of, what is the meaning? Effect of B, composition of B on FB means this is called self. Effect works back on the same species itself. That is B on B. So EBB. This is called self interaction coefficient. And this is again repeat. This is what? This will be what? EBC. Effect of concentration of C on Henrian activity coefficient of B, or simply activity coefficient of B. These are all about this. Effect of 8% B, concentration is 8% B on the activity coefficient of B, or when it will be C, the effect of concentration of C on the activity coefficient of B, Henrian activity coefficient. That I write here, clearly right there. So this is actually this one, here, right. Effect of C on Henrian activity coefficient of B on B, or shortest effect of C on B, effect of B on B, everything. These are the superscript. This goes to the superscript EBC. So where you can very easily yourself write a qualitative equation, give it as equation is what? Log of 9. It will be 9. Very important equation, very important 9. Where you just must clarify where, because I have defined it here. So 1, 2, 3, 4 are already defined, and now is the time for defining is. Where? Tell me yourself. You can get this. EBB is what? EBB what? This gentleman, write this. I wrote here also, but you cannot see perhaps. This one, write nicely. Del log FB 8% over del 8% B under the condition of 8% B is 0. Oh, this I have not written here. Okay. Oh, I'm writing. I'm writing. As it is written there, let me write first. 8% B is 0, 8% C is 0. But you know very well, meaningless. Both are B, so C has no role. So write once more, write what you will do. Write once more FB 8% over del 8% B only right now equals to that only 8% B is 0. And this is which property? Tell me which property? Binary property. AB. This is called your EBB. E, not epsilon. EBB. This is a property of the binary system. This is a property of the binary system. What system? Tell me. AB. A is the solvent, B is the solute, AB. C is absent, obviously. Good, binary, this done. And EBC, for EBB and EBC, I am writing this side to utilize the space. EBC is what? You tell me. EBC, clearly see here, this gentleman. EBC 8% C, I have written EBC 8%, this is EBC. Del log again, numerator FB 8%. over del weight percent C. Again I repeat, effect of weight percent C on FB. The FB is this one on FB. This is given by EBC. Effect of C. So interaction. That's why interaction of C with B. So under what condition? Tell me. Weight percent B is 0 as it should be. Weight percent B is 0. Weight percent C is 0. You know? That's it. You cannot. This is B. This is C. This is a ternary property. Ternary system. So this is a property of the ternary system. No, this is a property of the ternary system. This is a property of the ternary system. Okay, this is okay. Now okay, ABC. Now one thing I tell you, that means if you want to measure this value experimentally in your lab, in your project work, remember to find out this you need a ABC system, and this condition must be satisfied. That I have taught you how to get this 0 actually, somewhere, it takes same concentration of C and varying concentration of B, and they all are extrapolated back to 0, then plotted against weight percent C, and then take this weight percent C also in the 4th plot, maybe a 5th plot to 0. This I taught you. Okay, but ternary, this is binary. So this is a binary. When it is binary, then it is actually less, more relief than ternary. But anyway, ternary, if you have to evaluate, you have to experimentally find out, and then this is the ternary property. Okay, the system. So iron, manganese, carbon system. So, and when in that case, say iron, carbon system. Okay, this. Thank you. I'll actually where this is not required anymore. It's all done. I'm very sorry. Careful. This part I'm removing. These relations, defining relations. 1, 2, 3, 4, 5, 6. They will cover the 4 interrelationship that we are trying to find out. I've already given you at the top. This is our agenda. 4 interrelationship. The first one I've written here. Second one I'll write after my plan is to complete this first 2. Let us see how much I can do. And this space I will use so that you don't have any difficulty about relationships. Relations are all available. So draw a line. Above the line, some relation in terms of E interaction parameters, and below the line, below the lower boundary, these are the epsilon relationship. Good. But what is the job? Now take that. Now take the job. Now that all defining relations are obtained, we are in a position to take up the relation between epsilon B and now I tell you what these are called self interaction parameter. Self, both. This is epsilon type, this is E type. and just note, and in passing note, because I may forget myself, in passing we may note epsilon BC and EBC are called are called are called sorry are called called are called what? Ternary interaction parameter. This is cell B on B, C on C, B on that is cell, or B on C, or C on B, or okay, right, are called ternary interaction parameters. Quickly, very good. These are okay. Huh? Now this take up this. This is remember this is the first one. One. So start EBB. Start with definition. Don't get I from the definition. EBB here. Simplest. Del ln gamma b by del xb at xb is 0. Quickly, this is first principle. No problem. No, don't. No. Is what? Ln gamma b is what? I wrote here, helpfully here. What is ln gamma b? Tell me. Ln gamma b is what? Gamma b was what? FB mole fraction times gamma b 0. Fortunately, I saved this. How many minutes? 1 hour, 9 minutes, roughly. Achha, this one, at least one will be done. Okay. FB mole fraction. 9 minutes. See here. Gamma b is FB times FB mole fractions times gamma b 0. And also note at the same time FB mole fraction is FB weight percent. I will use them. So first of all this over del xb and give this at xb is 0. Keep on doing this. Is what? Del, you do this, break this, split this. This is ln FB mole fraction plus ln gamma b 0, log product over del xb at xb is 0. Happy? So this is again you see this is del ln FB mole fraction over del xb at xb is 0. Why this is true? Because ln gamma b 0 is a constant with respect to xb. Remember that is the idea of gamma b 0. Gamma b 0 does not change with Hindman activity coefficient gamma b 0. The gamma b 0 cannot change with composition. Gamma b can. So that's a linear part. Remember gamma b 0 for the linear part, activity versus composition linear. So the ratio is the activity coefficient, and that is constant for that domain over which it is linear. You know this. So since tell me gamma b 0 is not function of xb. Since gamma b 0 quickly since gamma b 0 is not function of gamma b 0 is a constant. Is a constant and not function. Is a constant. You're right. It's a constant and not function of xb. Happy? Okay. So this is simplification here. Now do one thing. I'm writing. Follow me. The ln FB mole fraction is same as FB weight percent. FB mole fraction is same as FB weight percent. Write that. Why I try to reach at FB weight percent, which is required for EBB. Connect EBB through weight percent, not X. So DLN and not only this log, not only ln but also log. So log FB weight percent. Follow me. over dxb, you write d weight percent. xb change to weight percent. Then you do this thing at where? And what you write outside? ln2 log is 2.303. Happy? Okay. So what I have done, ln fb log fb. FB mole fraction is same as fb weight percent. I have no worry. So ln fb weight percent is log fb weight percent times 2.303. Numerator is okay. xb have changed to weight percent b, but that will make up with this divided by del xb by del weight percent b at weight percent b is 0. Oh, this is such a small thing. I cannot do this. Write this, right? This is dxb, d weight percent b. So right here, compensate. Okay, okay. Cancellation dxb back, and right here again. This is xb is 0. xb is 0. Acha, by the way, I'm very sorry. Weight percent b is 0, and right weight percent b is 0. Why? Sir, you wrote xb is 0, you are writing weight percent b is 0 and weight percent b is 0. Why? Because when xb is 0, weight percent b is 0. So simple. So write what changes I made here. Right? Note this quickly, very quickly. Note 1. One that fb mole fraction is fb weight percent. Done. Secondly, what you note? Note 1. Note 2 is what? Weight percent b is 0 when xb is 0. When xb is 0, I had xb is 0, I have written weight percent b 0. No problem, same. What advantage of this? Shall I write this? Shall I at this moment? EBC, na? Acha. Okay. Shall I get some space? Where I'll get the space now? Where shall I get the space now? Is what? Quickly, very quickly. I don't have much time left. Very quickly. Shall I? I don't want to disturb much. Acha, I have to disturb this. No way. Next day I'll give you. Okay. This part. Otherwise I cannot. I don't have space. Continue. Now I'm almost done. Is what? Is tell me 2.303. What is this? Please tell me what is this? This is our desired. Our desired EBB. See, log B weight percent by weight percent, del weight percent B here, EBB. And the relation between EBB and epsilon BB here. So EBB come down here. Okay, came up here. Okay, and divided by this value. I'm giving the answer, but I'll show you soon. This is nothing but atomic weight of A, 100 atomic weight of B. Okay, so so this is okay. Okay, happy. So what is the relation? Hence, proof below. Proof given below quickly. And hence, tell me what is EBB? Write EBB on the left hand side. EBB is, you check this. This is nothing but atomic weight of A, 230.3 atomic weight of B times epsilon BB. Please check this. Epsilon BB. Okay, is this times atomic weight of A. Atomic, and this, suppose this goes to the other side, this goes to this side, atomic weight of A times epsilon BB, and this go, and this is, and this goes to this, and this will, this and this will be same. Okay, on the, this is here, and this goes to this other side. So this will, this and this will be multiplied. So it is 100 times 2.303 is simple math, simple, very simple, simplest. So 0.3 that I have written, and atomic weight of B. So this is the desired, this is the desired relation of, this is the, what is that? This is the required relationship between, this is the required relationship between epsilon BB and eBB. So I am removing this to proof. The proof I have said, proof is given below. What proof? This one. Proof. Quickly. 2 hours 1 minute. Okay, that's it. Proof. dxb del xb by del weight percent b. At weight percent b is 0. Quickly. What is this value? Tell me. What is the xb? xb is see here. xb is right. Del atomic weight of weight percent b. Write this. Weight percent b divided by atomic weight of A, weight percent B by plus atomic weight of B, weight percent A. Happy? This is dxb over del weight percent B, and the whole value at weight percent B is 0. Now quickly do one del weight percent. What is this? You know what? If you do this, consider weight percent B is what? Weight percent A. You write everything in terms of weight percent B. What is weight percent A? 100 minus weight percent B. So 100 minus weight percent B. So what is it? Atomic weight. So you get this. Let me write. The numerator I am not touching. Numerator is okay. What is this? Denominator. It is 100 minus weight percent B. So atomic weight of A. So weight percent B times atomic weight of A minus atomic weight of B. This is one term. 100 is there. 100 minus 100 atomic weight B plus 100 atomic weight B. Okay, divided by del weight percent B, and again write, very important,